The moon, of course, has been known since prehistoric times. It is the second brightest object in the sky after the sun. As the moon orbits around the Earth once per month, the angle between the Earth, the moon, and the sun changes. We see this as the cycle of the moon's phases. The time between successive new moons is 29.5 days, slightly different from the moon's orbital period, measured against the stars, since the Earth moves a significant distance in its orbit around the sun in that time. Due to its size and composition, the moon is sometimes classified as a terrestrial planet, along with Mercury, Venus, Earth, and Mars. The moon was first visited by the Soviet spacecraft Luna 2 in 1959. It is the only extraterrestrial body to have been visited by humans. The first landing was on July 20, 1969. The last was in December 1972. The moon is also the only body from which samples have been returned to Earth. In the summer of 1994, the moon was very extensively mapped by the little spacecraft Clementine and again in 1999 by Lunar Prospector. The gravitational forces between the Earth and the moon cause some interesting effects. The most obvious is the tides waters in oceans and seas. Actually, the moon appears to wobble a bit, due to its slightly non-circular orbit, so that a few degrees of the far side can be seen from time to time, but the majority of the far side was completely unknown until the Soviet spacecraft Luna 3 photographed it in 1959. There is no dark side of the moon. All parts of the moon get sunlight half the time except for a few deep craters near the poles. Some uses of the term dark side in the past may have referred to the far side as dark in the sense of unknown, but even that meaning is no longer valid today. The moon has no atmosphere. But evidence from suggested that there may be water ice in some deep craters near the moon's south pole which are permanently shaded. This has now been reinforced by data from Lunar Prospector. There is apparently ice at the North Pole as well. The moon's crust averages 68 kilometers thick and varies from essentially zero under Mare Crisium to 107 kilometers north of the crater Korolev on the lunar far side. Below the crust is a mantle and probably a small core. Unlike the Earth, however, the moon's interior is no longer active. Curiously, the moon's center of mass is offset from its geometric center by about 2 kilometers in the direction toward the Earth. There are two primary types of terrain on the moon, the heavily cratered and very old highlands and the relatively smooth and younger Maria. The Maria are huge impact craters that were later flooded by molten lava. Most of the surface is covered with regolith, a mixture of fine dust and rocky debris produced by meteor impacts. For some unknown reason, the Maria are concentrated on the near side. Most of the craters on the near side are named for famous figures in the history of science such as Tycho, Copernicus, and Ptolemaeus. Features on the far side have more modern references such as Apollo, Gagarin, and Korolev, with a distinctly Russian bias since the first images were obtained by Luna 3. In addition to the familiar features on the near side, the moon also has the huge craters South Pole-Aitken on the far side, which is 2,250 kilometers in diameter and 12 kilometers deep, making it the largest impact basin in the solar system, and Oriental on the western limb, which is a splendid example of a multi-ring crater. A total of 382 kilograms of rock samples were returned to the Earth by the Apollo and Luna programs. These provide most of our detailed knowledge of the moon. They are particularly valuable in that they can be dated. Even today, more than 30 years after the last moon landing, scientists still study these precious samples. Most rocks on the surface of the moon seem to be between 4.6 and 3 billion years old. This is a fortuitous match with the oldest terrestrial rocks, which are rarely more than 3 billion years old. Thus the moon provides evidence about the early history of the solar system not available on the Earth. Prior to the study of the Apollo samples, there was no consensus about the origin of the moon. There were three principal theories: co-accretion, which asserted that the Moon and the Earth formed at the same time from the solar nebula, fission, which asserted that the Moon split off of the Earth, and capture, which held that the Moon formed elsewhere and was subsequently captured by the Earth. None of these work very well. But the new and detailed information from the Moon rocks led to the impact theory, that the Earth collided with a very large object, as big as Mars or more, and that the Moon formed from the ejected material. There are still details to be worked out, but the impact theory is now widely accepted. The Moon has no global magnetic field, but some of its surface rocks exhibit remnant magnetism, indicating that there may have been a global magnetic field early in the Moon's history. With no atmosphere and no magnetic field, the Moon's surface is exposed directly to the solar wind. Over its 4 billion-year lifetime, many ions from the solar wind have become embedded in the Moon's regolith. Thus, samples of regolith returned by the Apollo missions proved valuable in studies of the solar wind. Interesting facts about Earth's moon. The Moon is estimated to be 4.5 billion years ago. We were not around to see its creation, but it was most likely made when a large object collided with Earth. This would have blasted out rocks that began to orbit around the Earth. These were then drawn together and over time melted into one another. Once they cooled down, they became the Moon. The Moon would have been hit by other rocks for 500 million years. These are rocks from the original collision, and this is why the Moon's surface is covered in craters, over 500,000 of them. The Moon is very visible from Earth. With a telescope or even a very good pair of binoculars, you can see the Moon's surface and its craters. The Moon is tidally locked to the Earth. This means that the same side of the Moon is facing the Earth at all times. Images have been captured from space that shows the opposite side to look very similar to what we can see. There is no atmosphere on the Moon. This is why the craters are still there, and there is no rain and wind or weather activity to erode the surface as we see on Earth. The Moon has seas. Not real oceans like we have on Earth, but large smooth pits of lava. These appear on the Moon as areas darker than the rest of the surface. Each sea has a Latin name. The Moon goes through phases. These happen when the Moon is lit differently by the Sun. The Moon appears to Earth as a small crescent. As it rotates around the Earth, this expands to a full moon and back to a small crescent. This happens once every 29 days and is called a lunar month. The Moon causes the rise and fall of the ocean's tides on Earth. This is because the Moon has a gravitational force which causes the oceans to bulge outwards on both sides of the planet. This is the Moon pulling the water towards itself. Due to the different rotations of the Earth and the Moon, the area of the planet affected changes throughout the day. This means any given area of Earth will experience a high tide caused by this bulge every 12 hours and 25 minutes. The Moon is slowly moving away from Earth. It is only going 3.8 centimeters away each year, and we won't notice a difference for some time. You weigh less on the Moon than you do on Earth. This is because the Moon has a much weaker level of gravity than Earth. This is due to the satellite's smaller mass. You would weigh about 16.5% of what you do on Earth. People have walked on the Moon, but only 12 of them, all of which were males. These were all part of the Apollo missions between 1968 and 1972. Nobody has been there since, but there are future plans to revisit the Moon. The Moon is the 5th largest natural satellite. It is only beaten in size by the very large moons of Jupiter and Saturn.